When we think of buildings, we often imagine them staying here forever, a static imprint. Here is a permanence of us that is unmovable, unyielding, and will outlive us. Architecture has long aspired to be the impression on the world that doesn't fade away. However, our world is changing due to our ever-increasing presence. An environmental crisis is to be expected when our lifestyles, built environment, and construction practices don't align with the flexible breadth of the natural world. Buildings can be examined as machines, just as the human body is. Programs to organs, corridors to circulation, designed to adapt to the given environment. Do building and engineered spaces breathe? Should they? What happens when architectural strength and spirit do not come from permanence, but growth? This question and surrounding research stem from the Picoplanktonics exhibition at the 2025 Venice Biennale. It's fitting to think of this exhibition through this year's theme: intelligence, natural, artificial, collective. Picoplanktonics presents a surreal yet realized vision of living architecture through a 3D printed core structure laced with microorganisms. The exhibition overgoes photosynthesis, mineralizing into built form over time. The limitations of such a project are also poetic in their mirroring of how life is raised. Like all living things, Picoplanktonics' biological functions depend on rigid environmental parameters. Temperature, nutrient delivery, and support were required to realize this project. The natural world needs care and concern to bear fruit. Likewise, so does architecture here. Back to the initial question Picoplanktonics raises. What happens when architectural strength and spirit do not come from permanence, but from growth? The research I would like to propose involves exploring this question through one of architecture's oldest friends, the humble brick. In short, I'd like to explore the fabrication of a mycelium brick, documenting the controls and parameters in context to its growth. This builds on Picoplanktonics' ideas about merging architecture with digital fabrication to create living environments. How will the brick respond to changes in the environment? What are the limitations? How does it interact with the natural world in Canadian contexts? I'm particularly interested in assessing how fragile or potentially resilient living architecture is. Our studio is not a highly specialized environment with advanced climate control capabilities. Can this one brick be grown on a smaller, humble scale, serving as a small window of knowledge into organic architecture in progress? In practice, growing the brick will involve combining mycelium with nutrients in a 3D printed mold, then storing it in a dark, humid environment. Over the course of the semester, I plan to watch the fungus spread through the structural substrate until a natural mass is formed. It's interesting to consider the architecture in this context, as the brick will need daily misting and checks to ensure it grows. The final product will not just be a designed object, but a collaboration between humans and organisms in design, guided by technologies. The mycelium will negotiate its push and pull on the mold, being denser in some areas and thinner in others. Is the extra care, patience, and unpredictability worth the final product? This is another question I hope to find insight into organic architecture. Further themes of the architect as caretaker in a discourse with nature, rather than as the sole designer, will also be explored. This research also explores resource management, social instability, and ecological relationships within the built environment, as contextualized in the World Economic Forum's Global Risks Report of 2025. The substrate of the brick's structure will likely be made of coffee grounds and sawdust, transforming waste into structure with the help of a fungal friend. Mycelium is known for its ability to sequester carbon, trapping it within our built world, and decomposing harmlessly at the end of its life rather than ending up in a landfill. These traits turn sustainability into a design process rather than a metric for assessing building performance. For the final submission, I plan to produce a short documentary on my findings and the brick's growth over the next month. Whether a full brick with generous growth is present in December or a dying husk of fungal spores, it will be insightful to see how the relationship between life and form operates on this small scale. In summary, this research challenges the idea that permanence equals value in architecture, and that the intelligence of architecture today does not rest in the resistance to time, but in the captivity to live, change, and decay as well.